Okay, hi everybody. As you see, I have a hoodie because I'm still cold despite being here for 2 years. My name is Luis, and I'm not the lord of the front end. I'm just senior front end at a Czech company called STRV. And that's my Twitter handle. I'll be putting the slides there later on. I'm going to check if this works. Oh, OK, yeah. So today I want to talk to you about giving you a few tips about optimizing React's TTI. And for those who don't know, TTI stands for time to interactive, which is just a fancy word to say when your application is actually ready to be used for your users. So technically, when all the JavaScript has been processed, the JavaScript thread is ready, and the browser is listening for user inputs. So we could get this metric if we use a tool like Lighthouse. Lighthouse is an audit tool that is embedded on the browser. So you just go to the audits tab in the Chrome Developers tool. You'll find it there. You'll run it against your website, and it will give you a bunch of stats and metrics. And of course, because we're talking about performance, we will care only about the one that is performance. So imagine that we have a React SPA that we built with Create React App or similar. And we start with this score, which is probably not that bad, but it could be way, way better. So we need to do something about it, and that's why I'm going to give you some tips for it. So the first thing is to understand how the SPA interacts with the browser. There's going to be a super oversimplified version of it because there are many things that are happening behind the scenes, and CSS is not going to be taken into account. But the first thing after some DNS resolution is that we're going to get a super tiny HTML. This is because technically there is nothing there besides some script tags and probably some CSS. So after we get the HTML, we're going to start fetching our JavaScript. And imagine that the user is trying to access your website on a 3G connection. So it's going to take a while to load your JavaScript. So it's been 1 second. There's nothing on the screen. Many users at this point will leave your website. And then after downloading your script, they have to wait for parsing, compiling, and script evaluation. So 3 seconds, nothing on the screen, so it's super boring for the users. Some of them might leave your website by this point. But what happens later is that React paints the actual application, and you get something like a shell, usually, like the header, the footer, some non-dynamic stuff. And you usually have to fetch the rest of the data later. So you have a loader there, you get the rest of your data, and then you have a fully rendered application. So this took a lot of time. So let's try to do better. And to do it, we'll have to use SSR or server-side rendering, or we could use a static export. So the situation will paint a little bit different when we use SSR. Or HTML is going to be generated on the server, so it's going to be a bigger HTML. It will take longer to load, but once it's loaded, along with the CSS, the user could see a fully rendered application much, much earlier in the process than if you're using just an SPA. So for example, here, it's been 1 second, and the user already has the fully rendered application, and there is no even JavaScript running on the application yet. This is what's called the first meaningful paint. And then the script evaluation will pretty much take the same time as SPA. There's no difference there. And then we'll have some rehydration. This process might be faster than constructing all the website after you get the JavaScript as opposed to with the SPA. But in general, what matters here is that we move early on the first meaningful paint. And this will improve the perceived performance for the end user. So we can effectively increase our score. It will look to the user as the page loaded much, much faster than it actually did. So the users will be happy about it. But the truth is that I kind of lied. There is a big downside of using server-side rendering, besides complexity issues. But if we just care about performance, there are two main problems here. The first time is that we'll have increased response times, because now if you're using, this only applies for dynamic server-side rendering, but your web application has to be recreated on each request. And this takes a lot of CPU time. And the more requests that we have, the slower it will get the server to respond. So technically, we just made everything worse. So there are two ways to solve it. One is use a server-side render app shell, which means that we would just create the bare minimums, so something like this, and we will just create a static export of this. So we won't need a server, we'll just create this HTML, and we will send this to the user when they load the website. So at least, even if there's no content there, it will look like the app is already loaded, and this will improve also the perception. But in the case that you need SEO support, or you want to really show all the content to the user, the way to do it is by using server-side caching. And there are many ways to do this, but of course, I will be showing you some simplified version, and it's pretty straightforward. So imagine that you have like a Node.js server and a handler for your specific page or for all the pages. Caching is just an empty object. That's pretty much it. You just check if the URL that is being requested is on the cache. If it is not, then you will use render to string, get the HTML, put it on the cache, and return it to the user. That's it. And for the next user, you would just return the URL, the cache version of this. So as you can see, it's pretty straightforward. But we need a way to invalidate this cache, because if your API data changes, maybe your products changes, you need a way to delete that cache. And the simple way to do it is you create some sort of hook that your API will call whenever there is a change. So if somebody change a product, post, they will call this endpoint. You will have to, of course, put some security checks there. But in general, you just wipe out the cache by replacing it by a new object, and that's it. You will get up-to-date data, and this is much, much faster than creating a build every single time that your product changes. You could have updated data in a second instead of waiting 5 minutes to get the updated data. So it really depends on your use case. You can be more granular in the sense that if you just want to remove some part of your cache, if just the products change, you would just remove the pages that are related to that. You can get as complicated as you want, but the whole approach is the same. So with this, we got better, but it's still not the same score that I promised initially. And this is because there is a issue that is not so obvious, but it's called a false sense of interactivity. As you can see, at 1 second, we have our application, and there is no JavaScript. So for the end user, it looks like it's technically loaded, but then they try to use it. They try typing here, clicking here and there, and nothing is working because, again, JavaScript is still not being evaluated. So for the users, it's like a pretty sad story. They will feel like they have something in front of them, but it is not actually there. And when this happens, your users will get mad, and there will be a lot of rage clicking, and you definitely don't want users mad. So the way to solve this is with something called progressive enhancement. It's pretty simple. You just take every interactive element, like buttons or similar, And you have to choose how you are going to present those elements while JavaScript is still not ready. So one simple way is to change them for loaders, fade the opacity of the button, hide them, somehow hint the user that the element is not ready. So for example, here if we change that submit button with just a loader, the user at least will be aware that something is going on there. So it's not like the page is broken, it's just that, okay, maybe this part is not ready. And we could, for example, leverage some functionality to CSS. If we can make this navigation with only CSS, it will be the best. And if we need to enhance it with JavaScript later, okay, great. But at least while it's loading, it should at least work with CSS. And also you can leverage with to some basic HTML functionality, like submitting form. That search bar could be done with only HTML if needed. So just try to provide the minimal experience to the user while there's no JavaScript, and then you will improve it. And with this, we actually get the score that I promised you initially. So now there is a round for next round of tips. For that, we need to understand the life cycle of JavaScript. What's actually happening? You get the file from the browser, you download it. It's recommended that you use gzip. So the browser has to uncompress that file and then parse it, then compile it, and then evaluate it or run it. So there's a lot of steps here, and we usually just think in terms of download. Some browsers, like for example Chrome, can download and chunks by chunks start parsing and compiling, but not all browsers can do this. So you need to consider that there will be some extra time just for parsing and compiling before even running your code. So with that, it's important that you start by knowing your bundle size. How you do that? You could use something like Webpack Bundle Analyzer. Just run it against your website, and it will give you this graph where you can see how your application actually looks. So you can see what are the big libraries that you have. So for example, if you have Mama.js, it will look kind of big over there. And it will just give you a better understanding of what's going on. So the tip is make it small. How do we do that? We avoid big libraries. There are plugins that you could use in your editor to see how big the import is. But probably unless it is you want to do it on a project that already exists, it's probably too late just to do that. So it's better to use something like bundle PHOBIA, where you can go to the website and type the bundle, the package that you want, that you're interested in npm, and find how big it is. So for example, if you type for Mama.js, you hit enter, you get this. With a bunch of stats. So you can easily see how big it is, the minify version and the gzip version. I recommend that you not only pay attention to the gzip version, because the minify version is what is going to affect your memory usage, because this is ultimately going to be uncompressed on gzip in the browser. So sometimes some files can be gzip very good, but the uncompressed version is quite big, so you need to be aware of that. But most importantly is the download time. You need to pay attention of how many seconds it could add to this to your website. So in 3G, 1.3 seconds, it's something to consider. With that, another performance boost. And the other trick that we could do to make our bundle smaller is using code splitting. So code splitting is about taking this big bundle and making it into different chunks. So the easiest way, and this is something that you technically should do every single time, is to use route level code splitting. This means that every single page will be a separate bundle. So it will look like this. So if you have for every page, you will have a separate bundle, and you will have a shared bundle between them. So instead of delivering the whole thing to the end user, you will just send the common shared bundle plus the page that they're currently looking. And this is probably the thing that will improve your, you get a lot of performance benefits just by doing this. And there are other approaches that we could do. We could take it further, but these ones are to be used with caution, because route level code splitting, I mean, there might be some cases where you don't need it, but it's probably not common. But these others really depend on your use case. You have to be really careful. But for example, if you have a video lightbox, for example, something like this, that you have a YouTube video, when you click on the button, get a lightbox. If you have a YouTube video, you will have to download a third-party library that has to be evaluated and all this stuff. And on the initial load, this will block the user. This will prevent the user from interacting with your website with something that maybe is not used right away. So you want to use dynamic import and suspense, just as it is with the route level code splitting. You will probably want to do this here, and then you will avoid adding extra code to the browser to parse. And also another trick, this is also not for every website, but if your app is pretty long, maybe you have a really long landing page, you can probably, the second part, the part that is below the default, you can probably group all of this into a dynamically import component and just load that second part when the user scroll beyond that section. So with that, you get some performance improvements. And the last thing that I would like you to talk about is page trackers. We really need this. It's technically used in every production-ready website. And I mean Google Analytics, Mixpanel, Google Tag Manager, or similar. And we cannot remove them. Our business needed to understand how our users are interacting with our websites. So we need a way to solve some of the issues that adding third-party libraries will add, because they will hurt your time to interactive a lot. For every single library that you add, you could be adding between 50 to 150 milliseconds where your users cannot interact with your website because the browser is parsing, compiling, and running the analytics code just for the initial instantiation. But we can do something about it. So if we take a look at, for example, Google Analytics, this is unreadable, of course, but there are two parts of this for this code, and this is very similar in all page trackers. The part in yellow is just adding a script tag, is adding this Google Analytics /analytics.js file, and that's pretty straightforward. There's nothing magical here. The interesting part is the other part of the code, which is, of course, is still unreadable, so let's make it better. It's just adding a global function. This global function, we attach a global array, that's called Q, as a property to it. And every time that this function is called, it's just going to put those arguments that were passed to it into this array. So when you put real data, it looks something like this. So you put, if you pass send and page view, it would add those into the array. And those will be added into, once the analytics.js loads, it will take all those, everything that is in the array and send it back to Google. So Google is doing this because it's obvious that you will not have this library ready when your application loads. So the user is starting to send events like page view and all this stuff, and analytics.js is probably not loaded yet. So they need a way to cover their tracks. So once they have this special queue just to do that, and we can take advantage of this. We create an object like this, and we put inside an init function that takes a delay. The first thing we do is put the part that was just responsible for adding that global function here. And with that, we have the function and the queue. And the second thing is inside a set timeout, we put the other part, the part that adds the script tag. And then we just have a helper function just to help us track the events. So with this, in our application, it's pretty straightforward. We just, let's say we have use effect. And the first thing we do is we initialize our trackers. So let's say we put, hey, we want to defer this tracker 5 seconds. You have to play around with this number. It really depends on your application, but maybe 5 seconds is a good number. And you can start tracking events. And these events are just being stored into this array. And this array is just once 5 seconds pass and the analytics.js loads, it would take everything on the queue, send it back to Google Analytics. So you won't lose any events, but you won't be blocking the JavaScript thread with this. So with that, we will probably gain a lot of performance boost. And this, of course, depends if you have many analytics in your website. The more you have, the better performance improvement you get. And there are two ways to deal with multiple analytics. You could just apply this to any of those. So for if you have Mixpanel or Tag Manager, you will do something similar. But there is another way. You could just use Google Tag Manager, and inside Google Tag Manager, manage all your analytics. And in there, they have a dashboard where you can defer all the elements, all the other page trackers there. But you will need to apply this trick to Google Tag Manager, because that one will also be a script that has to be downloaded, and it will block it will slow down your TTI. So if you do that just to Google Tag Manager and defer the rest inside the dashboard, you're all set. There are, of course, some further improvements that you could do. For example, you could use tree shaking, and you could use, for example, if you're using Lodash or Lambda, you normally don't want to use to import the whole bundle. You want to just use like simple functions. So you could use like a Babel plugin to get transform the imports that you use to get a better reduced file size. Of course, I cannot cover many more stuff. So just remember that the lower your TTI, probably you will have happier users, and that's what ultimately matters. So that's it.